So welcome students. In this video, let us look at the topic of the maximum and minimum values of trigonometric expressions. So we know that all trigonometric ratios cannot take all possible real values. That is, if you take sine theta, what is the range of sine theta? Sine theta always belongs to -1, 1. It means the maximum value of sine theta is +1 and the minimum value of sine theta is -1. And the same case with cos theta, this also belongs to -1 to +1. So what I'm writing is the ranges of the trigonometric functions. Next, tan theta and cot theta. So they can take all real values from -infinity to +infinity. And what about secant and cosecant? So cosecant theta and secant theta, they belong to -infinity to -1 union 1, infinity. So these are the ranges of individual trigonometric functions. Now, if some expressions of these trigonometric functions are given and you're asked to find the maximum and minimum values of those expressions, so how do we do this? That's what we deal in this topic. So for example, so let's go from the easier examples to difficult examples. So if you're given sine square theta, so find the maximum and minimum values of sine square theta. That means effectively find the range of sine square theta. So how do we get the range of this? The range of sine square theta can be obtained from the knowledge of the range of sine. So if you have sine theta, we know that it belongs to -1, 1. Now if you square it, so if sine theta belongs to -1 to 1, sine square theta obviously will be less than or equal to 1 and goes from 0, because once you square it, the negative values will become positive values and they lie between 0 and 1. That means the maximum value of sine square theta is +1 and the minimum value of sine square theta is 0. So I hope you have understood how we get from this to this. So sine theta lies between -1 and +1. So if you square it, so the numbers between 0 to 1, on squaring also goes between 0 to 1. The numbers between 0 to -1, on squaring again comes back to 0 to 1. So all the values lies between 0 to 1. Now if I ask you what the range of cos square theta is, cos square theta also by the same process has to belong to 0 to 1, right? So till here it is very easy. Now if you have some complicated expressions of sine and cos, for example, if I give you an expression of theta is equal to sine square theta plus cos square theta, this is a very easy example, but just let us try to see this. So if I have sine square theta plus cos square theta, and if I ask you what's the range of sine square theta plus cos square theta, so what you tend to do is sine square theta belongs to 0 to 1 and cos square theta also belong to 0 to 1. Now if I add these two values, the number that I get might belong to 0 to 2, right? Because this is in between 0 to 1, this is in between 0 to 1. Now if I add these two, 0 plus 0, the minimum value might be 0 and 1 plus 1, the maximum value will be 2. So I tend to write that 0 is the minimum value and 2 is the maximum value. But that's not the case, as you know. We know that sine square theta plus cos square theta is always equal to 1. So the range of f of theta is only 1. But if you directly analyze the individual functions and add the ranges of those two, so you get a wrong answer, right? So this is what you need to observe. What is wrong in this process? The thing that is wrong in this process is this theta and this theta are same. So sine theta and cos theta values are depending on each other. That is, sine theta individually, sine square theta individually can go from 0 to 1. Cos square theta individually can go from 0 to 1. But they cannot vary independently. That is, if sine theta is equal to 0, cos theta has to be equal to 1. So if sine theta has some particular value, cos theta cannot have a range of values. So these two numbers are depending on each other, and they are depending in such a way that their sum is always equal to 1. So I cannot individually add the ranges of the individual functions. So that's what you need to remember. Be careful in this topic. So now let us go for some other standard types of expressions that you might encounter often. So one of the important type of trigonometric expression that you'll come across is f of theta is equal to a cos theta plus b sin theta. This is the most important. So how do we analyze this? Let us take an example. So let f of theta is equal to sin theta plus cos theta. So you're asked to find the maximum and minimum value of this expression. So now what you tend to do again is sin theta, we know that it lies between -1 and +1. Cos theta also we know that it lies between -1 and +1. So now if you add these two functions, so you might tend to say that the range of this is in between -2 to +2, because when this is -1 and this is -1, you get the sum as -2, and when this is 1 and this is 1, you get the sum as +2, and you mark this answer and you get it wrong. So what's wrong in this range? So the thing that is wrong in this type of dealing is that again you're assuming sin theta and cos theta are independent of each other. That means when sin theta is equal to -1, you're assuming that cos theta is also simultaneously can be equal to -1. But we know that sin theta and cos theta depend on each other. So when sin is equal to -1, cos cannot be equal to -1, because we know that sin square theta plus cos square theta has to be equal to 1. So obviously cannot take -1 and -1 simultaneously and say that this expression can take value of -2. So this expression cannot take value of -2. And similarly, when sin theta is equal to 1, cos theta cannot be equal to 1. Cos theta has to be equal to 0. So this type of dealing is wrong because these two expressions depend on each other. Now how do we deal with this? One of the way is f of theta is equal to, this is a very intuitive way, sin theta plus cos theta. So what I do is I'll divide this with √2 and multiply this with √2. So let us see why we are doing this afterwards. So for now, suppose that I'll multiply and divide with √2. So that is equal to, so this is sin theta times 1 by √2 plus cos theta times 1 by √2 times √2, right? And we know that 1 by √2 is something like cos 45. 1 by √2 is also something like sin 45. So this looks like sin theta cos 45 plus cos theta sin 45. This is nothing but sin of theta plus pi by 4. So sin of theta plus pi by 4 times √2. That means this expression sin theta plus cos theta can be written as √2 times sin of theta plus pi by 4. Effectively, I have converted two trigonometric ratios into a single trigonometric ratio. Now I can analyze the range of f of theta. Now sin of theta plus pi by 4, whatever goes inside sin of theta plus pi by 4 always lies between -1 and +1. And you are uniformly multiplying each and every value with √2. So the range of sin theta plus cos theta is nothing but -√2 to √2, closed. That means both are included. That means what is the maximum value of sin theta plus cos theta? √2. And what is the minimum value? -√2. That's the answer to this question. So it is quite counterintuitive if you think in terms of -2 to +2. Next, let us take another example. So let us take the next example as f of theta is equal to cos theta plus √3 sin theta. So what is the maximum and minimum value of this trigonometric expression? So now again, you cannot do this because sin theta and cos theta are depending on each other. Their values depend on each other. Now what you do is, this time I'll multiply numerator and denominator with 2. So I'll multiply it with 2. So that is equal to 2 times cos theta into 1 by 2 can be written as sine of pi by 6. And sine theta into root 3 by 2 can be written as cos of pi by 6. So this can be written as sine of theta plus pi by 6 plus 30 degrees. Now again, the expression is being converted into a single trigonometric ratio. Now I can analyze this. This lies between -1 and +1. So 2 times of this lies between -2 and +2. Hence, the maximum value of cos theta plus root 3 sin theta is +2. Cos theta plus root 3 sin theta minimum value is -2. So can you see this process? So what I'm effectively doing is I'm converting an expression containing 2 different trigonometric ratios into an expression containing only 1 trigonometric ratio. And how am I doing it? I am multiplying and dividing the expression with some suitable number. In the first question I have divided and multiplied with root 2. The second question by 2. So now we are going to see the logic by which we can get this number. So what is the process by which I can get this number for different trigonometric expressions of the form a cos theta plus b sin theta? So now let us closely look at the process by which you can convert this expression containing 2 trigonometric ratios into an expression containing only 1 trigonometric ratio. So f of theta is equal to a cos theta plus b sin theta. So what I say is this a and b are 2 real numbers. So I'll construct a right angle triangle. Whose side is equal to a and b. Whose right angle sides are equal to a and b. So obviously if I have 2 numbers, I can always construct a right angle triangle with these 2 numbers as the sides. Now let the angle formed here be equal to alpha. You have some angle, right? I don't know what that angle is, but you get some angle in this triangle. Now if these 2 sides are a and b, what is the hypotenuse of this? The hypotenuse is root of a square plus b square. So now what I do for this expression is, so a cos theta plus b sin theta. So I'll multiply and divide the expression with root of a square plus b square. So let us see what simplification you get by dividing this with root of a square plus b square. So that is equal to, so now this root of a square plus b square belongs to the first term as well as the second term. Now this can be written as cos theta times a by root of a square plus b square, a by root of a square plus b square. That is, opposite side by hypotenuse is nothing but sin alpha, right? So a by root of a square plus b square can be written as sin alpha plus b by root of a square plus b square can be written as cos alpha sin theta times root of a square plus b square. So that can be written as root of a square plus b square times the expression inside the bracket is of the form sin a cos b plus cos a sin b. Sin a cos b plus cos a sin b, that's the compound angle formula for sin of a plus b. So this can be written as sin of theta plus alpha. Now the expression in 2 trigonometric ratios has been converted into 1 trigonometric ratio. Now we have only sin of some angle where theta is changing. So as theta changes, sin of theta plus alpha belongs to -1 to +1, right? Because the range of sin theta is -1 to +1. So sin of theta plus alpha also lies between -1 and +1. So if you are multiplying this with root of a square plus b square uniformly, so what is the range of this expression? The range of this expression is minus root of a square plus b square to plus root of a square plus b square. It means the maximum value of f of theta is root of a square plus b square. The minimum value of a cos theta plus b sin theta is minus root of a square plus b square. So this is a process by which we do. But for competitive examinations, you can directly remember this formula. Once you understand the logic of this, the maximum value of a cos theta plus b sin theta is root of a square plus b square, and the minimum value is minus root of a square plus b square, where a and b are the constants which are being multiplied with sin theta and cos theta. So for example, so if you are asked to find the range of 3 cos theta plus 4 sin theta, So what is the maximum and minimum value of this expression? 3 cos theta plus 4 sin theta. The answer would be root of 3 square plus 4 square plus or minus root of 3 square plus 4 square. That is equal to plus or minus 5. That is plus 5 is the maximum value, minus 5 is the minimum value. So I'm not doing the derivation. From the next time you can directly get the answer. Whenever you see some numbers being multiplied with cos theta and sin theta, this is the answer. So let us take another example. This time let us take a slightly non-obvious example. So if you have 3 cos theta plus 4 times sine of theta plus pi by 6. Now what is the maximum and minimum value of this expression? So here you cannot directly use the formula. So this formula is only for a cos theta plus b sin theta. So this is of the form a cos theta plus b sin theta plus something. You cannot directly use this formula, but this question can be converted into a question of this type by using compound angle formulas. So this can be written as 3 cos theta plus 4 times sine of theta plus pi by 6 is sine theta cos pi by 6 plus cos theta sine pi by 6. So that can be written as 3 cos theta plus 4 times cos 30 degrees is root 3 by 2. So root 3 by 2 into 4 is 2 root 3 sine theta plus cos theta into sine pi by 6 is 1 by 2. So 1 by 2 into 4 is 2. So 2 cos theta. So effectively this expression is nothing but 3 cos theta plus 2 cos theta is 5 cos theta plus 2 root 3 sine theta. So now this has been converted into standard form. Now I can use the formula. The range is plus or minus 5 square plus 2 root 3 whole square. That is equal to plus or minus root of 25 plus 2 root 3 whole square is 4 into 3, 12. That is equal to plus or minus root of 37. So the maximum value of this expression is plus root 37 and the minimum value of this expression is minus root 37. So now I hope you have understood this formula. So even after you understand this formula, you have to be very clear in mind what you're doing and why you're doing this. Because you can go wrong if you blindly remember this formula and the question given is this. So let us say that an expression is given which is 3 cos alpha plus 4 sine beta. This is an expression in alpha and beta where alpha and beta can vary independently. So now what is the range of this expression? So here theta and theta are depending on each other. If by chance you're given a question where you have 3 cos alpha plus 4 sine beta where alpha and beta can change independently. So what is the range of this? Here you have to use the original process, because if these two change independently, then cos alpha and sine beta's values are also independent of each other. So 3 cos alpha lies between minus 3 to plus 3 and 4 sine beta lies between minus 4 to plus 4, and when you add them the range becomes minus 7 to plus 7. So here you can add the ranges because these two are independent of each other. So you have to see in the question whether the two angles are dependent on each other or independent of each other. If they are dependent and is of the form a cos theta plus b sin theta, then root of a square plus b square plus or minus are the maximum and minimum values.